Happy Friday, class. Today we'll be going over the binomial theorem and Pascal's triangle. The first thing, as usual, homework. Homework problems here. Each one is worth 5 points each. Once you checked it and recorded your scores, please turn them in. So first things first, we're going to be looking at our binomial expansion. Again, binomial dealing with two terms. If we take a look at expanding our x plus y, here we have to the 0th power first all the way down to the 5th power with all the terms associated with it. If we look at this, we can see certain patterns. Several things for us that we can see is that in each expansion we have n plus 1 terms. Here with that first degree we have 2 terms. Here with our 4th degree we have 1, 2, 3, 4, 5 terms. This is true about all these, and we're going to have those n plus 1 terms. In each expansion, x and y also has symmetric roles. The powers of x, we take a look, to the 5th, to the 4th, to the 3rd, to the 2nd, to the 1st, to the 0th power. So we can see that they are actually decreasing by 1. And at the same time, the powers of y are increasing by 1. If we look at each term, we can see that when we add up the powers of each term, here again looking at the power to the 5th, we have power of 5. Here our exponents, add them up, 4 plus 1 gives us 5, 3 plus 2, 2 plus 3, 1 plus 4. All of them give us that same power, that power of 5 or that power of n. So here we have that the sum of the powers of each term is just n. And lastly, if we look at the coefficients, here we can see we have a 1, 5, 10, 10, 5, 1, 1, 4, 6, 4, 1. We can see that the coefficients increase and also decrease in a symmetric pattern. We're going to come up with these coefficients to make it easier. There is something we can use, our binomial coefficient, to come up with those, each and all of those coefficients. So we get that with our binomial theorem. Binomial theorem says that the coefficients of binomial expansion, first things are called our binomial coefficients. To find them, we use that binomial theorem. So again, if we look at that x plus y to the nth power, x to the n, again, then the powers of my x decrease by 1, so x to the n minus 1, and so forth, where my y powers are increasing. But our coefficient, here we have that coefficient of x to the n minus r times y to the r. This symbol here we read as n choose r. This will be the coefficient of that x to the n minus r, y to the r term. It's also written as lowercase n, a large c, and an r on the right side. These are all just about factorials, where this all equals my n factorial over n minus r factorial times r factorial. So to find that coefficient of that term, again, we're just doing that n factorial over the two other factorials, n minus r factorial and r factorial. So let's find the binomial coefficients. In this particular one, we have 9 choose 2. So what this means again is my 9 factorial over 9 minus 2 factorial times 2 factorial, or just 9 factorial over 7 factorial times 2 factorial. Simplifying, right? We write that expansion on out to where we can cancel things out. So the 7's on down to the 1's canceling. And here this 2 goes into 8 4 times. 9 times 4 gives us at 36. Number B, part B, we have that 11 choose 4. So that's our 11 factorial over 11 minus 4 factorial. So our 7 factorial times 4 factorial. So 11 times 10, always on down to 7, because we know we're going to be canceling out with that 7 factorial. And I still have my 4 times 3 times 2 times the understood 1. So what cancels? Well, my 7's cancel. And here 4 times 2, that's 8. Canceling with the 8. And our 3 going into 9 3 times. So here we have 11 times 10 times 3, giving us 330. For C, we have 8 choose 0. So I have my 8 factorial over 8 minus 0 factorial, which is just 8 factorial, times 0 factorial. Again, 0 factorial is just 1. So we have our 8 factorial over 8 factorial, which just gives us 1. Here we have, in D, 5 choose 5. 5 factorial over 5 minus 5, 0 factorial times r factorial, 5 factorial. And again, we wind up with the same thing with our 0 factorial equaling 1. So here you can see in both situations, when you have n choose n or n choose 0, you're always going to come up with a coefficient here of 1. So let's apply this to finding those binomial coefficients. So if we remember that the coefficient for our x to the n minus r power, y to the r power, it's going to be that n choose r. We want to find the 6th term of the expansion of x plus y to the 8th. So first let's find the coefficient. So that coefficient, again, our n choose r, or in this case my n is 8, the r is 6. So from here we get that 8 factorial over 8 minus 6, 2 factorial times r factorial. Simplifying, we have 8 times 7 times 6. We're going to be canceling out with that 6 factorial. And we have the 2 at the bottom going into 8 4 times. So from here we wind up with our 7 times 4, our 28, being that coefficient for that particular space. So we have, for our 6th term, we're going to have that 28. But then what are the powers of the x and the y? We know again that x is decreasing, starting off with that 8th power, or starting off with x to the 8th. And we're looking at the 6th term, so my 8 minus 6, I'm going to be at x squared, and y is increasing, starting off with that 0 on up to the 6. So this gives us that we are, the 6th term for the expansion of x plus y to the 8th is just 28 times x squared y to the 6. For this one, we need to remember, right, we're looking at the 5th term of a plus 2b to the 8th power. So here, what is going on with the coefficient for my a to the n minus r, 2b to the r? It's going to be that exact thing, a choose 2b. So again, here we're looking for the 5th term of an 8th power. So my coefficient is going to be 8 choose 5. So here we get our 8 factorial over 3 factorial times 5 factorial. So what cancels? Again, all the 5's, and at the bottom we have a 3 times 2 times 1 over 6, canceling there. So we know that the coefficient, 8 times 7, is 56. So now for our fifth term, I know I have 56 as a coefficient. And the first term is my A. And we're looking at the fifth term. So again, it started off at the eighth. So now it's going to be down to the third, right? 8, 7, 6, 5, 4, 3. And then our other term, 2b, it is also to the fifth power. But we don't leave it like this, right? We have to find out, simplify. So a to the third power, and that fifth power, that 2b to the fifth, my 2 is also raised to the fifth power. 2 to the fifth, to the fifth is just 32. So now our 32 times 56, giving us 1,792, which I know all of you did in your head. So here that fifth term would be 1,792, a to the third, b to the fifth. Here we want to find the coefficient of the term a to the fourth, b to the seventh, in the expansion of 2a minus 3b to the 11th. So here we're looking for that seventh term. Again, this right here tells us what term we're looking for, that seventh term. And it's expansion to the 11th degree, so our coefficient 11 choose 7. So 11 factorial over 11 minus 7. So our 11 minus 7 is going to be 4 factorial over 7 factorial. And our 4 factorial, canceling and simplifying. 4 times 2 is 8. Once again, we have that 11 times 10 times 3, which we did previously, giving us a coefficient of 330. So we have our seventh term will be our 330. Our first term was 2a to the fourth and negative 3b to the seventh. Again, we get that fourth, that's the term we're looking for our first term, and the seventh for that second term. But now we have to take care of that 2 and that negative 3. So here we have our 330, 2 to the fourth, 16a to the fourth, and negative 3 to the seventh, negative 2,187, b to the seventh. And now what? Again, we have to multiply, get just one coefficient, very small number, quite manageable, negative 11,547,360, a to the fourth, d to the seventh. Especially for homework and some of these problems, you may want to use a calculator, unless you feel you can do it in your head. Kudos to you if you can. But again, don't expect stuff like this on a test or a quiz without using a calculator. But do know how to apply all this. Again, these numbers may not be as big on a test or a quiz, but you should know how to come up with the solutions, or at least setting it up. Another way that we can come up with these coefficients, binomial expansion, is looking at Pascal's triangle. Pascal's triangle, it's a triangle with all the coefficients of our binomial expansion. It starts off with having ones on the outside. So we start off at the top, constructing a triangle, putting our ones down here. And ones are always going to go on the ends. In the middle stuff, we just take the addition of the two terms. So here, that 1 plus 1 gives us 2. Now here, 1 plus 2 gives us 3. 2 plus 1 gives us 3. And again, on the outsides, we put our 1s. Outside I'm putting my 1, but 1 plus 3 gives me 4. 3 plus 3 gives me 6. 3 plus 1 gives me 4. That's I have 1. And we just keep on going. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. This is what we get with Pascal's triangle. It just goes on and on. But as you can see, if we take a look at this, comparing the triangle with the coefficients, at 0th row, on down to the 7th row, here we have row 1, where we have the coefficients of 1, 1, comparing right up here. With our 0, x plus y, they both have coefficients of 1. Here, row 2, 1, 2, 1. If we take a look, we have our coefficient of 1, coefficient of 2, coefficient of 1, all the way on down to, if we go to our row 5, which is where we expanded it to the 5th degree, it says that we should have coefficients of 1, 5, 10, 10, 5, 1. Sure enough, 1, 5, 10, 10, 5, 1. Again, we can also get that just by doing our n choose r. Pascal's triangle, it also gives us those coefficients just like that as well. So, here we want to use Pascal's triangle to write the expansion of x plus y to the 7th. So for x plus y to the 7th, we're taking a look at our row 7. Again, starting off with x plus y to the 7th, x is going to have that 7th degree, y is going to have that 0th degree. So our coefficients of our 1 times x to the 7th plus the next coefficient of 7. X has decreased by a power, so x to the 6th, and now y is increasing. And keep on going on down, 21 x to the 5th y squared. So just by using the coefficients here, my 1, 7, 21, 35, 21, 7, and 1, putting those out in front, and then again, decreasing the powers of my x and increasing the powers of my y, we come up with that x to the 7th plus 7x to the 6y plus 21 x to the 5th y squared plus 35 x to the 4th y cubed, always on down to that y to the 7th. So Pascal's triangle, you don't have to worry about doing that n choose r. You just go ahead and copy down those coefficients or write down those coefficients along with your associated x and y powers. So here, we want to write the expansion for x plus 2 to the 4th. So here we're using our row 4 of 1, 4, 6, 4, and 1. So that gives us, starting off with our x to the 4th, coefficient of 1. And then I have my coefficient of 4, so x cubed y. The next one, coefficient of 6, x squared y squared. And then we're at 4. And finally, that last one, plus, oh, let's back up here a sec. We aren't doing x plus y to the 4th. We're doing x plus 2 to the 4th. So let's try that again. That was coefficient of 1. Gives us that x to the 4th, and then a coefficient of 4, x cubed. We didn't have y, but we actually have 2, plus 6, x squared, and then our 2 squared. And we're down to a coefficient of 4, x to the 3rd power, and finally we're down to a coefficient of 1, where 2 is to the 4th power. So now we want to simplify. And we come up with x to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. Don't leave your answer with 2 squared, 2 to the 4th, anything like that. Again, multiply that on out. Here you can see we get that x to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. Here we're going to write the expansion for y minus 2 to the 4th power. Again, our coefficients from Pascal's triangle would have been 1, 4, 6, 4, 1. So here we come up with y to the fourth plus 4 y cubed negative 2 to the first plus 6y squared negative 2 squared plus 4y times negative 2 cubed, and lastly negative 2 to the fourth. Again, simplifying, and negative 2 to the first, negative 2 to the second, negative 2 to the third, and negative 2 to the fourth gives us y to the fourth minus 8y cubed plus 24 y squared minus 32y plus 16. If you notice, what did that negative do? All it did was alternate the signs, negative, positive, negative, and so forth. So whenever we have x minus y to some nth power, all we're doing is alternating signs. You don't have to worry about putting in that negative there. Just remember it's going to go positive, starting off with that very first coefficient, and then just alternating positive, negative, positive, negative. So here we're going to write the expansion of 2x minus y to the fourth. Once again, we're having a fourth power, so it's just 1, 4, 6, 4, and 1 from Pascal's triangle. My first term is 2x. So we have 2x to the fourth power, and now I have a coefficient of 4. So since we're alternating signs, minus 4 to the times 2x to the third power y. Again, alternating signs, plus 6, 2x squared, y squared. Alternating sign, minus 4 times 2x, y to the third power, and lastly, plus y to the fourth. So again, I didn't have to worry about this minus y, as long as I remember to alternate my signs, minus, plus, minus, plus. So when we simplify, we wind up here with 16x minus 32x cubed y plus 24x squared y squared minus 8y cubed plus y to the fourth. One more problem to go, folks. Let's take a look at this one. We're going to write the expansion for 3 plus x squared to the third power. So binomial expansion for 3, our coefficients from Pascal's triangle, 1, 3, 3, 1. So here that first term is 3, coefficient of 1, so we have 3 to the third power, right, using my first term. And now that coefficient of 3, and our first term now is 3 squared. And I also have my x squared term, x squared to that first power. And I have my coefficient of 3. And now my first term has already decreased down to the first power, where my x squared term has increased to the second power. And lastly, that last term, our x squared, gets that power of 3. So here, expanding on out, again, my 3 cubed gives me that 27. And here, 3 times 3 squared, 27 x squared. 3 times 3, giving us that 9. And then x squared squared. Again, we multiply our exponents, x to the fourth. And that last term, x squared to the third power, gives us x to the 6th. So whether we decide to use the binomial coefficients by coming up with our n choose r using the factorials, or even constructing Pascal's triangle, 2 ways of coming up with an expansion for your binomials. And here's your homework. Enjoy, and I will see you all on Monday. Please remember, if you didn't, Monday or Tuesday, bring in your textbooks.